In this video, we're going to talk about how to multiply rational expressions. So you remember how to multiply fractions? When you multiply fractions, it's helpful to start off by simplifying the fractions before multiplying. So if we look at this problem here, you notice that 15 and 3 have a common factor of 3. So we're going to reduce both of these to 5 and 1. 22 and 121 have a common factor of 11. So we're going to reduce these to 2 and 11. Now we multiply the numerators together, so we have 5 times 11, and then we multiply the denominators together, so we have 2 times 1, which gives us 55 over 2. So we're going to use a similar idea when we multiply rational expressions. You're going to start off by factoring the numerator and denominator of both fractions, then cancel any common factors, multiply the numerators together, and then multiply the denominators together. So let's try this example. So we start off by factoring the first numerator. So I'm going to factor x squared minus 4x plus 3. So when I factor this, I'm going to look for two factors of 3 that add up to negative 4. Well, since 3 is positive, both my factors are going to have the same sign. Since 4 is negative, that same sign is going to be both negative. So 3 only has two factors, which are 1 and 3, so I'm going to make both negative, which does give me negative 4. So that means that the factored form of this expression is x minus 1 times x minus 3. Now let's try factoring 2x plus 2. When we factor 2x plus 2, notice that we do have a GCF. The GCF of both these terms is 2. So I can factor a 2 out, so we have 2 times 2x over 2 plus 2 over 2. So that reduces to 2 times 2 and 2 cancel, so we have x plus 2 divided by 2 is 1. So this will become 2 times x plus 1. Now let's factor 4. 4 is just a whole number, so 4 is going to factor to 2 times 2. We just write it as the product of its prime factors. And now let's factor x squared plus 2x minus 15. So when we factor that, we're going to look for two factors of negative 15 that add up to 2. Since 15 is negative, I'm going to have two factors with opposite sign. Since 2 is positive, the bigger factor is going to be positive. So we have 1 and 15, and then 3 and 5. So the correct combination of factors is going to be negative 3 and 5, which does give me 2. So that means the factored form is x minus 3 times x plus 5. So now let's rewrite this original problem with all the numerators and denominators factored. So we have x minus 1 times x minus 3 over 2 times x plus 1 times, and then we have 2 times 2 in the numerator over x minus 3 times x plus 5. So now we can cancel any common factors as long as they're on the opposite side of a fraction, right? Like 1 in the numerator, 1 in the denominator, or 1 in the denominator and 1 in the numerator. So this x minus 3 and x minus 3 will cancel. 2 and 2 will cancel, and then we're just going to multiply everything we have left. So the numerator is going to be 2 times x minus 1, and then the denominator is going to be x plus 1 times x plus 5. And that is now our final answer. So now let's try multiplying these two fractions. So we have x minus 5 over 4x cubed and 8x over 3 times x minus 5. So this is sort of already factored for us. So we can just go ahead and look for our common factors. So we have x minus 5, and then we have 4x cubed times 8x over 3 times x minus 5. So notice that this x minus 5 and x minus 5 will cancel. And then here we have an x in the numerator, and so that's going to cancel out one of these x's from the denominator. Okay, so that's going to leave me with an x squared. If you want, instead, you can write this like totally factored out. You can write this as 2 times 2 times x times x times x, and then times, let's see, it's going to be 2 times 2 times 2 times x. If you want to write it as a prime factored expression, you can do that too. That way you can see what I'm canceling. So I canceled an x and I canceled an x here. That's what left me with two x's. And then the 8 and 4 will reduce, right? So this will become 1 and this will become 2. If you do it in the factored form, you can cancel out 2 2's here and then 2 2's here. And then don't forget the x minus 5. When we finally multiply the numerators together, we're going to end up with 2 over the denominators, which is 3x squared. So it's the same answer you get either way. Here you'll see the numerator, all we have left is a 2. So we have 2 over and then 3, and then we have 2x's left, so 3x squared. So now let's try multiplying these two expressions. So let's factor the first numerator. We have x squared minus 16. This is one of those special factoring patterns, right? Because this is the difference of two squares. So we have x squared minus 4 squared, so that can be rewritten as x plus 4 times x minus 4. X plus 4 can't be factored any further. And then we have 2x, so we're just going to write that as 2 times x. And then we have 2x minus 8, which does have a GCF, right? Notice that 2 will evenly divide both these terms. So we pull out the 2, and then we divide what we have left by 2. And so that will give us 2 times, then we have x minus 8 divided by 2, which is 4. So now let's write this problem with everything all factored out. So we have x plus 4 times x minus 4 over, and then we have x plus 4 times 2 times x over 2 times x minus 4. So let's cancel our common factors. So we have an x plus 4, and then we have an x minus 4, and then 2 and 2 will cancel. So this whole entire expression just simplifies to x over 1, which is equal to just x. So now let's try multiplying these two expressions together. So once again, we're just going to go through and factor everything. So we have x squared minus 3x. Notice that we have a GCF of x. So I'm going to factor an x out of both terms. So I have x squared minus 3x. And divide out the x. So I have x times x minus 3. And now let's factor x squared minus 7x plus 12. So we need two factors of 12 that are going to add up to negative 7. Since 12 is positive, both my factors are going to have the same sign. Since 7 is negative, that sign is going to be negative on both. So we have negative 1, negative 12, negative 2, negative 6, and negative 3, negative 4. Notice that negative 3, negative 4 is the correct combination. So we have x minus 3 times x minus 4. Now let's factor x squared minus 6x plus 8. So when we do this, we have 8. So 8 is positive, so my factors are going to be both positive or both negative. 6 is negative, so both my factors are going to be negative. So I have negative 1, negative 8, negative 2, negative 4, and that is what gives me the correct combination. So my factored expression is x minus 2 times x minus 4. And now finally we have x to the 4th plus x squared. So if we look at these two terms, we have a GCF. Notice that I can factor an x squared out of both terms. So when I factor out an x squared, I have x to the 4th over x squared plus x squared over x squared. So that leaves me with x squared times x to the 4th over x squared is going to reduce to just x squared. And then x squared over x squared is just plus 1. So now that everything's all factored out, I can rewrite my expression. So I have, let's see, I have x times x minus 3 over, and then my denominator is going to be x minus 3 times x minus 4. And then multiplied by my numerator, which is x minus 2, x minus 4. And the final denominator, which is x squared times x squared plus 1. So now let's cancel out all our common factors. So we have an x minus 3 and an x minus 3. We have an x minus 4 and an x minus 4. And now we have an x and an x squared, so I can factor out one x, right? This x squared is basically x times x. So I can cancel one x, and so that leaves me with just x. And then everything else cannot be further simplified. So in the numerator, we just have left an x minus 2. And then in the denominator, we have x times x squared plus 1. And that is our final answer. So now you can go ahead and pause the video and try this practice problem on your own. So when you do this problem, if you factor the first numerator, you get x plus 2 times x plus 2. X plus 3 is prime, so we're just going to leave that alone. Then we have x squared minus 9, which is the difference of 2 squared, so that gives us x plus 3 times x minus 3. And then we have x squared plus 6x plus 8, which factors to x plus 2 times x plus 4. When we rewrite this problem in fully factored form, these common factors of x plus 2 and x plus 2 will cancel, and x plus 3 and x plus 3 cancel. So that leaves us with x plus 2 times x minus 3 over x plus 4. So remember, you can multiply rational expressions using these following steps. First, factor the numerator and denominator of both fractions, cancel any common factors, then multiply the numerators together and multiply the denominators together.